Okay, so in this video, we're going to start looking at the binomial distribution. So a binomial distribution, for a start, we need to be able to be clear that it's a discrete distribution. So by discrete, that means it is counted. So anything that is counted is discrete, and anything that's measured is continuous. Now, we will only have two discrete distributions, the binomial and the Poisson, and we will have three continuous distributions, which is the normal, the uniform, and the triangular. So given the fact that I know some is counted, it gives me a hint about which distribution I'm going to be using. So remember, we're talking about counted stuff, not measured stuff. Okay, so that's my first thing. So for first thing for binomial, I need to identify it's discrete. The second thing I need to know is I have four things that I need to make sure are true. And I use the acronym PIT to help me remember these conditions. Now, you're going to need to remember these conditions, and not only that, you're going to need to be able to apply these conditions. So the P stands for probability. Is fixed. Now, what I mean by that is you're going to do the same test multiple times. And every single one of those tests is going to be a success or fail test. Therefore, the probability needs to be fixed every single time so it doesn't change between how many times you do it. And the second one, which leads from that, is independence. And it kind of follows from the probability is fixed, but the binomial distribution grew out of a tree diagram. So therefore, we know to use a tree diagram and go along the branches, each one has to be independent. Otherwise, that doesn't work. Okay, so independence is the next one. And then the T stands for two outcomes. Oops, started doing that wrong. I was doing the wrong two. Okay, binomial, bi means two. So two outcomes is my third condition. And the last outcome, or the last condition, is a number of trials that is fixed. Now, what I mean by that is that there are a set number of things that you're going to repeat when those are called your trials, and you've got a total number of those that's fixed. Okay, and so knowing these conditions is all well and good, but it's really important that you can apply those to a situation. So on the right hand side of the screen, from the moment this video was started, I have a situation, and my situation tells me a supermarket has 8 employees who are on call. Based on their records, the probability of these employees being unavailable is estimated to be 0.14. Okay, so what we're going to do for the next little bit of this video, and probably that's going to be the end of this video actually, is we're going to fix and we're going to answer the second part of the question first. Okay, because we're just applying these 4 conditions to this situation. So let's go through. First off, is the situation I'm working on discrete? Well, number of employees is something I can count. So yes, it is. So that's a big tick for it being a binomial. Is the probability fixed? Well, they're telling me the probability is 0.14. So historically, their probability is fixed. They know on average an employee being unavailable is 0.14, and they're saying that they've got a large enough sample, so that's fair enough. If I phoned multiple members of these 8 and asked them, are you available to work, they're not going to know that the last person said that they were unavailable, so that's not going to affect. So they are independent. Are there 2 outcomes? An employee, when we phone them, is either going to be available or unavailable. 2 outcomes. And are there a fixed number of trials? Well, I've got 8 people to phone as my cover. There are only 2 outcomes. There are only a fixed number of trials for people who I can get there. There are only the 8 who are on call. So I'm pretty certain that this is a binomial, and I can justify that in the context that it's going. And it's really important that you can do that in the context, because if you don't do it in the context, it's not going to be sufficient to get you the mark. And this generally is worth more than just achieved. Okay, so that's the binomial distribution. I haven't even looked at the formula. I'm probably not going to even look at the formula. If you want to look at the review for the standard that's on the website, it's available for you, and use that. Okay, but applying the conditions to a situation, I can do that, and that's definitely a binomial. Okay, so that's the first video. The next video is going to be actually using the graphics calculator to calculate the probability. I will be using an FX Casio graphics calculator to do that, and so we will talk about that in the next video. Okay, have a great day.